Okay, so now we move into the third session where we would like to, this is interactive now really, we're going to go into the nuts and bolts of it, and this is the time to say yes, but, and what about there, and yeah, but if you added that or whatever. This is now we're into the real hardcore stuff here. Okay, so we're going to, for the purpose of demonstration, start off with a blank area of a tin.
I'm going to look at the configuration first of all, so the metadata configuration. So you guys are all sort of used to this now, S-point, M-point, they all look the same. So you can just change it for each of your features. Okay, so endpoint's obviously a little bit different to S-points. Don't need a return number on a contour, for instance. So we've taken what they've called the return number and we've changed it to something that's useful for us, so the source. And if I show you what we mean by source, under populate tables, we've got LiDAR photogrammetry. So where do these contours come from? How were they made? Okay.
So we can also add have profiles there that we can set up. Typically, ESCOM uses the AKZ code format, and they use that for their point clouds. And so every single nut and every bolt has got a code, and it's all fitted into this metadata. So, but yeah, we're doing a classical field survey information for contours. Okay. So you can say, okay, I will stick with the default name of feature code, but for source ID, I'm going to have surveyor. Now let's just say we say, no, I don't want surveyor because I work with a bunch of suppliers or whatever. So we change the name to supplier. From then on, everything in the system is going to say supplier. It's not going to say surveyor. So when you see your tabs, remember that hover, when you hover over the contour, it's not going to say surveyor, it's going to say the supplier is Geo or whoever. Okay. And you can add all your suppliers now. You might give each supplier a number and say, okay, your ID is 100. And then when you hover over that contour, it finds that the supplier's ID is 100 and looks up the name and pops up the name and says, okay, this is Justin Yule's survey, did this. Each of those tabs you can configure. And then one of them is the date, of course. So if you said, well, I don't want GPS date and time, I just want normal date and time, then you choose it over there.
So it's available for your S-points as well.
So you set up your metadata information. Most of the setting up here would happen for your feature codes. So we give you a bunch of profiles for default feature codes. Karen clicks on the list there all the way from -1 meter up to, 25 meter. And so as it's placing, it knows you're choosing your feature code, whatever project you're working on. That information is handled now by the configuration. Okay, what particular profile you're using. And so you just start your survey and it's going to be the right feature. Feature code is probably one of the most important thing. If we're going to refeaturize, we're going to look at that feature code to know how to refeaturize. So you go and change what the appearance of your feature is. We got to go and look for something that's attached to the element. The element is a -1. We go find -1 and we refeaturize according to what the changes that you've made for that -1. And that's how we're able to refeaturize. So you can make a new -1 that's completely different, and that's fine, as long as you use the same feature code when you create that new -1. The contour interval, so that would be a -1 now because it's a contour interval. The height tolerance not used much except for stereo plotters and that type of thing. For the dot roll contours, just checking the stereo plotter that you don't go out of range and things. So that's not really relevant to field surveys. And what we do suggest is that you graphically group these items. And so what is actually happening there? The line has then some kind of an ID that lets it know which text labels belong with that contour, which tick marks belong with it, and they're all in a group together. And so we suggested that you leave that on. You don't have to, but we do suggest it quite strongly. So we're into the nuts and bolts of setting up a particular feature here now. So just to sort of reinforce that if Corin changes to a different feature code. 5 meter, okay, and that's the color for the 5 meter contour line. It's giving you an example there. It's showing you exactly what that major contour line is going to look like, giving you the sample. Okay, you change it, what your weight's going to be. To avoid having to set the contour line for the labels and the ticks or whatever, you can lock it. So if you change the one, the other one changes. But if you do want a separate color, different color, then you unlock it and you make your changes. So there's the length of the ticks and the spacing of the ticks, and those are all scaled according to the scale that you're working at. Eh? So they will change so that your final product is always the same on your output. The label, you can decide over there whether to draw it, the number of digits before and after. Once again, you can lock them so that when you change the one, the other one changes. And this is the one that I was referring to about the clip type. So when it clips out that area for the label in your contour, we suggest that you use clip with construction. So it's going to leave that portion in there. You export to your shapefile, no problem, one continuous contour. Otherwise, you end up with 2 separate pieces, or alternatively, you can have with no clip, and then it just draws the label on the contour. Or if you give it an offset, then it will just be offset on the contour. And here's the direction type we're referring to. So you would have your direction type according to the cut line that you've drawn, according to a specific direction that you key in. Sheet dependent, and the new one that was added, upright sheet dependent. User info, so you can add user information the same way with your S points. Most times I would guess you would add user information that you don't display graphically. However, if you want to, you can have that information displayed, but most times you would add extra information about that contour. 2 types of user information, 1 and 2. 255 characters, quite a lot of information that you can add about each contour in user 1 and user 2, another 255. Okay, and then you could use that for further filtering your data. And here are the defaults for the metadata. So let's say you're now going to start your survey today, and you want to make sure that all your contour lines are now today's date. Then you would come and set your date here for the year, and this would be the default. You don't have to go and edit the contour or anything. When you create your contour now, it's going to have that date on it. You can change this while you edit. This is what will just simply be added as a default when any contour is created.
Okay, so we're going to look at the contour place. You all know this dialog box, but what we've done now is we've added profiles, so you can sort everything together. Obviously, you get this profile from us with the release, but we put automatic S-lines, M-shapes, dynamic S-lines, all the things that you guys are used to and have been using. All right, so that's still there. And then under item, I've just put together all the typical intervals that you would use, but you can add any to those. It lists the features. Okay, so it lists, you choose your minor and major feature as they appear in this list.
Just remember that this is what you see in the mini-me, because that's all you're really interested in at the end of the day. Once you've set all of this information and you set your features and you set your tolerance, like for a particular survey, you might have the sharpening factor or your smoothing factor. You really don't need to look at it again. Okay, you choose it, and that is why that information, by changing that type or item, all your settings that you've chosen will be. Prior to this, you had to go and change your setting now for let's say your smoothing. Let's take a simple one, smoothing factors. Now for this particular job, I don't want smoothing. Okay, I want lines or whatever. Another job I want is a high smoothing factor. Then you got to remember, okay, now which one? Or change your configuration file. That was the previous method of doing it. Now you just choose your type and item on the list, and then you know your smoothing is correct for that particular client to their standards.
And also per scale, obviously your smoothing parameters change. So especially these ones, the minimums and maximums change according to the size of your triangles. So it depends on the job. And now it's much easier it's stored in the profile, so you just select it from the list. You don't have to remember, oh, okay, if I'm doing this type of job, smoothing factors have to be this. It gets quite tedious, so now it's easy.
And I'm sure you recognize that this dialog box looks very similar to what it was, with the difference that you've got this profile type and item, and you've got your feature now, your major and your minor feature sitting there. Any questions about that before we go into the details of actually placing?
I'm just not quite following your mini-me. So usually I would click on your symbology and your uSMART and your far right, and the contours would come up. How does the mini-me panel fall into place? I'm not...
Just imagine this dialog box, and we chopped this off over here, and that didn't come up. So that's what you're going to see in your mini-me. Without the heading, so change that to the mini-me and pull that out here. Just move it right out. That's that same dialog box, just in a small form. Because once you've done your settings, and it's highly unlikely that you're now going to need to set it up again. Well, let's add a profile now. You'd go to the profile, you choose you're going to add either a type or item, because it's just, the types and items are just purely a way of organizing your thinking, you know, it's a tree. I've got a type with all these items and another type with all these items. So your type might be your job scale. For 1 in 500, I've got all these various options, and for 1 in 1,000, I've got these various options. When you add one, you add either type or item, and then it takes the one that you're on and makes a copy of it. So all you do is you choose the one that best suits what you've already got. You say add the item, it adds it with all the same settings, and now you go and you change the smoothing factor. Okay, so let's do that. We change the smoothing factor there, so we've got a new type. After you've done that, you just say file save. And the reason why we want you to save is so that if you really make a mess, you can just go out. Okay, now that's it. From this day onwards, we have a type and item of that. We go out just to prove it, shut down the job. That's stored. So what's actually happened is it's storing that information in an XML file. If you want to go and edit that XML file, it's a standard text file. You can use it. You can go and you might globally want to go and change all your smoothing factors and use a text editor and say, find all the 8s and make them 12s. They weren't smoothing enough. You know, advanced editing, then you might go into an editor. So it's writing to an XML file, store that information in the XML file, and comes up where you were last. With that particular profile. Now you can see once you've changed your smoothing factor, you know that PLG is going to you have a smoothing factor of 12. You never worry about it again. Why must you take up so much space for all of this information? Just dock it. And we make a mini-me out of it. And there it is where you last made it, but typically we pack them all on top of each other. Because if you pack them on top of each other, all you do is you use your scroll bar and it will go through place, edit, all the contour ones. Typically you pack up the contour ones all on top of each other. Okay, so we're going to contour an area. Okay, so we have now contoured that area, and we're going to do a little bit of editing just to reinforce what we showed you in the beginning. We didn't run that in the background, by the way. We could have chosen to run that in the background because it's a small area. We decided to just run it straight here. When you run it in the background, you'll see that like DOS window pop up. If you're not happy with it, you've forgotten some setting, you just close that, and it will then bring back your control.
So we're just going to work through the profiles that's going to be available to you guys. So this is pretty much what you're going to get. We might add 1 or 2 after this. So we've done all the clipping stuff. I'm not going to go through that. I'm going to show you a delete. So we're going to delete by Z range. So over there we chose Z range. And if I show you how I'm getting to a delete under specified changes, I'm just choosing to delete. Okay, and I'm going to delete everything below 200 and above 250. And there we go. All right, as quick as that. And then you might decide, no, I don't actually want to delete it. I want to change the color. So you say change the color, don't delete them. And now instead of deleting them, we're changing the color. All right, so you could add another profile to do that.
If you look at this, you can see this dialog box is an extension of that dialog box, okay? These are the changes. When you press that button, this dialog box pops up, okay? These are the changes that you actually want to make. Do you want to delete? Do you want to refeaturize? So once again, these are used even less than the rest of the items over here, so that they opened with a separate dialog box. The specified changes. What are the actual changes you want to make now? I want to change the color or whatever. At that time, you can add user info. At that time, you can change the surveyor. So, or you forgot to put the date on all the contours. You go and enter a date, and you just simply create a new type and item and say replace date. You enter your new date over there now, not as the default, and run through the whole job, and it fixes the date for the whole survey. Because imagine if you'd now put the wrong date in. Now, how do you do it now? Okay, now start over again. Go and do my survey, all my contours over. No. You just come and change the date over here. You switch on that button over there, and you say, I want to change the date, please. Okay. But now you do it often. You know, I did this last time. I forgot the date. I had to go and switch on the button or whatever. Let me make a profile, type an item, and I'm going to say, fix my date. And I'm going to call my profile item that. And then you don't go and look. The only thing you've got to do is go and key in the date, of course.
Okay, so we also just want to make you aware, if I just do a reload here quickly, so if I do make a mess of it, the reload will just take it back to where it was, is the area option. So you might say, okay, I don't want to do the whole area, just want to go inside my rectangle, and I'm not going to switch on the overlap, and we're going to delete inside there. Okay.
So now we've still got the height. We're still working within that height range, but we've added a further constraint. And we said, no, only within that area, and remove the height. Let's say all the contours are wrong. Something went wrong above a certain height. Now we can fix them and recontour those ones. And you've gone to a lot of trouble. You've labeled all the other contours now and everything, and you've got all the tools now to do it.
So we also added by start and Z increment, which was a request. So I'm going to delete all the odd numbered contours now. Right, so we'll only be left over with all the even ones.
Once again, hovering over with any of the tools that are open for that, you will see the information, the contour, the height, what it is, the feature code. It's repeated quite a few times in the class there, but sometimes it's quite useful. When we get to the filter, we're going to show you that in a few minutes. You can have combinations of all these filters. So you can have, say, this surveyor on this date and those major contours. Only show me that. Or only edit that. Whatever you want. You make all the combinations that you want.
So we're going to make some depression contours over here. So we tell it to recreate them, and we specify, I have to choose the right thing. Depression contours, specify the major and minor for the depression contours.
So as Corin changed, it changed the major and it said, I want to refeaturize major and minor. Yeah, we used to have separate tools for creating depression contours. It's all in one dialog box now. Okay, you choose that and then it sets it up for you. So it's created these depression contours. Let's just validate that they really are correct.
Switch on my filter.
So now all we're seeing is depression contours. And we can check, yeah, but it is a hole in the ground. And they are depression contours, if you wanted to.
Okay, the other thing that might happen is that you actually didn't want to have curves. You needed to make line strings. A lot of people actually want line strings, not curves.
Just zoom in there so we can see what we're talking about into any of these curves. You can see they smooth curves over there. Now you want to export to a package that doesn't support curves. It's just lines, but now you've gone to all the work to make this pretty plan. And now we're going to refeaturize them at line strings at a particular tolerance where we specify how much the line is allowed to deviate from the curve. Okay, and that's over here. Where's the tolerance over there. So we know that there won't be more than a 5 centimeter deviation from the contour. And we've got something that on far, when you zoomed out, looks like curves, but close up you'll see it's a polyline. And then your GIS system will probably be happy with it.
We're just going to find some crossing contours. I know sometimes it's a problem. We'll hope that doesn't happen, but sometimes it does happen. So
if you, in theory, if your dam is rock solid, you won't get crossing contours, okay? But it happens. Your dam is just not dense enough to control the contours enough. So what's actually happened here is identified the crossing contours, given you a listing of that. Looks a little bit not too useful, but what we've added is tools that will, and this could come from any source. This could come from an external ASCII file that you imported, but it's generated this file now. And all Corin has to do is press F7 and it'll pan to those places. It'll go to those coordinates of those places. If you forget F7, you just look on the list there. And it's taken us now to that place. It circled it, said, okay, there's a problem over there. Not in the S.1, because this happens so often, these circles are very dynamic. So they switch on, they disappear when you fix the problem. This is currently, it's just displaying it and you just clean up the data afterwards. So you might decide, okay, well, there's obviously a serious problem there. We're going to delete that node. And if you want to move on to the next one, she just simply presses F7 over here, and it takes you, and using the coordinates there, it's now finding that area. Just to sort of restate that, even though we generated a list of coordinates, you can generate a list of coordinates from whatever format, import it into here, and then press F7, and it'll use those coordinates here in any format. And we'll pan and find, you might use it for cadastral purposes to find your properties or whatever. We have other tools for that. I'm just saying that it is an option. And so there you can see she's now actually moving them using that those editing tools that we started out with. We don't have to now pull each vertex like that and nudge it across one by one.
Just do some labeling again, just to remind you guys this. Okay, so as it always was.
And gaps in the data? If you have contour data that got gaps in?
You mean like a complete break? Like, you mean you're actually going to draw? You're just speaking from a photogrammetric point of view. So you're actually going to add the contours in. Yeah, you can just add the contours, not a problem, and label it as before. Yeah.
Regarding the movement on your contours, you're moving the XY position. Does this affect the Z? Because on your triangles, your Z is going to be different from the contour that you just moved. So how do we get an accurate result?
It's not linked to the triangles when you it picks up the height of the contour, knows the height of the contour, and it will hold it at that height. So if you're moving a contour at 100, it's going to stay at 100 and insert. So you don't. I know it's quite a hassle because you would either have to have switched on AccuSnap or set your active Z or whatever. Now you don't worry about it at all. You just pick the contour and it's got the height of the contour and it's moving X or Y. There's a move option where you specifically say move X, Y, and Z, but the default is not to move the Z. Okay, so you're only moving the X and Y. So if you looked at that three-dimensionally, it doesn't matter what angle and what view. You could do it in isometric, it wouldn't matter. It would move it in the X and Y, yeah.
What about break lines? So typically you would have a LiDAR point cloud covering the terrain, and the surveyor would then survey the curb, which is a break line. Now,
Yeah.
how would you force the contour over that break line?
So during the creation process, the automatic process, you give it a weighting factor for your break lines, so you can decide what the weighting factor is for the break lines. One of the as you see, we're going through this process where we making features out of everything. At the moment, the triangles are relatively dumb. Okay, the triangles are triangles, and they're used for contours, and you can do volumes, and you can shade them, and you can do these kind of things. But now, obviously, we're adding the features for each. So you could literally identify, during that process, you can identify every single brake line if you wanted to, and have different features of brake lines. So you might say, for example, now you can do the same thing, but you'd have to do it in an individual process. Whereas once you've got features, you could say, okay, my road edge has a weighting factor of 2, but my stream has a weighting factor of 3, for example, or whatever, or maybe probably the other way around. And so your stream might have a gentler turn or whatever in it, because the stream is not going to have a sharp edge, whereas a road edge would have typically a sharp edge, and then you would push up the weighting factor. So you can do that now, but you'd have to first run your road edges and give it that weighting factor, and then your each individually. Where once you've got the features, then it knows, okay, it's coming from a road edge, featureize it, and I must get this weight for my brake line. Yeah.
The nodes on the contour, I presume they've got nothing to do with the crossings of the S lines. So it's to do with the smoothing.
It depends on how you set up the automatic creation. So when you set up the creation, if you have to change all of these to zeros and you give it a 0 smoothing factor, your contour is going to go exactly through that triangle's edge at that point, and you're going to get a node at that point. An exact node at that point. So it depends on how. So if Corin switches on the nodes, because of the way we did it over here, this has got a lot of nodes it's going to show, but you can see that they don't necessarily go through the triangles. It's more concerned about giving you smooth contours, for example. So it will, because of the tolerances that we gave it, it will move the contour, allow the contour to shift a little bit to that. But that's all dependent on you. And so your client might say, no, just give me straight lines for contours. They must go exactly through those triangle corners. You switch all of those off, you make a profile out of it, and you write their difficult client or whatever you want, or precise client, let's put it that way. Okay, so it depends on how you're going to deal with it. So if you start putting in smoothing factors, then the nodes and the actual triangles, they won't match. Because it has to, it pulls it, and it's going to pull it, yeah.
Okay, so if I go back to the process of editing a contour, then how do I know how far I'm deviating from my tin?
Yeah. So there's a couple of options with that. What you could do is that we've got the S-line tracking that will actually show you dynamically as you're moving how far you off your surface and what the X, Y, and Z value is at that point in time. So that would be one way, is as you're moving it. So yes, you could do it like that. But the point is that this is for everything for the future. So your road and everything where you know now, but the road must go through this point. I've got a point there on the ground, the road, and now I missed it or whatever. So now I want to pull, but there's a few other things because I drew it parallel to something else, and I want to move it. So if you can maybe think along those lines, then you'll start seeing, okay, well, for contours, you might say, well, I've got a contour over there, 100, and I've got another contour over here that's 102, and in between I've got a dead area, you know. Typically, my XY position is halfway between these two contours. But that doesn't stop you from switching on your triangle tracking again, and it will tell you at that point, it will give you the height at that point. But very often now you're trying to find a happy medium because your dam is not that good in that area. It's a little bad because, like if you were running drones, there was a tree there. So now there's no dam under the tree, you know. But for LiDAR, you would have got another return from the ground, so you then switch off your tree. But for autocorrelation, you would have the tree canopy, for example, if it was dense, and you might not have a point on the ground. So now you're sitting and you're feeling it, to tell you the truth. But you can the total triangle that covers. The total triangle that covers the whole area around the outside of the tree, you can still use that, you know, but who's to say that the ground's not doing this or it's not doing this below the tree? Well, typically it might do that, you know. So you're feeling it at that point in time.
Can we edit these in 3D? with the triangles on, so I can see it all in relation to the
Yes.
the tin.
Yes. Yeah. So what we're doing, remember our contouring routines, just about everything that we do in uSMART, we continuously thinking of the 3D component. So if you wanted to contour a wall or water tank or whatever, the only thing you've got to do is give it your perspective. So where am I looking from? And you typically do that by your view. So you would say, okay, please give me, you identify a few points on the, and look at it from here. And then you would be able to contour that whole wall, okay, from that perspective. And that's now a flat wall, but it can be a silo tank or whatever you want to. So you don't need to, contours don't have to, in uSMART, they don't need to be points that are equivalent height on the surface of the earth. You know, if you had to look up the definition of contour, you can contour the wall and you can contour at any perspective that you want to.
I can make an isometric view, see my contours, edit them, so I can visually see what's happening on. And obviously your S-line topology, you can also shade it, which helps a lot. So you can see the shading.
Kind of goes in with that other question of, now when I pick that contour, is the height going to stay the same? Yes. In a 3D environment, it's going to stay flat to the thing because you can't. Okay, but when you're working on the ground, then it's going to pick the height of that contour.
First of all, I'm very impressed with those editing tools. I mean, they are extremely useful. Now, in our case in the city, we have a LiDAR point cloud, which is massive. So let's say we've got those 8 billion points, and we generate contours. Then we improve the contours, and we do editing of those contours. So then a month later, we discover that a few points in the LiDAR point cloud have an error, like there's a spike in the data. So we fix the spike and regenerate the contours. Now when we regenerate the contours, we run it overnight, and a day later we have a new contours, then we lost all those edits. Now how do we deal with that? Say we take the point cloud and we run the contours in uSMART. Now then a month later we have a spike in the data. And we regenerate the contours. What happens to the edits?
Just want to say that you don't have to rerun all the contours. So once you've, it's in an area. So if you edited that area where you found the spike, you don't necessarily have to rerun all the contours. Or you can switch off with your filter the contours that you have painstakingly edited and just rerun the other ones. And if you have to then fix those ones that you've edited already, you can do that. So there's a couple of ways that you could approach this to not lose all your hard work.
I think if we can try and just answer you in another way, with the new metadata information, okay, so prior to this, you would have said, okay, well, now what I'm going to do is I'm going to take all the contours on this level, and I'm going to shift a level to another level, to call it old level or whatever. And then it's fine, you can read, so Corin's saying you could do it like this. What we would suggest with the new one is you give it a new metadata information, and you say either by date, this was before that date, and you switch off your auto delete button, which deletes the contours when you run them, okay, and then you just generate it in that area, and you will have the old contours and you will have the new contours, and you can filter them in or out by using your metadata. Now it would be much more efficient now to use your metadata and to start swapping levels, etc. So there are numerous solutions, but I think the metadata you might find would be a better solution now that the metadata has been added. And then you could say, you could come up either with a dating system, or that user one, you might identify and say the user one is version 1, version 2, version 3 of the, and you've got all your different versions of your contours, and you can just switch them on and off. And remember, when I say switch them on and off, there's a knock-on effect all the way through. So what you're seeing visually is then what you get if you export to a shapefile. Now you want to get it into your GIS system or whatever. So you switch off the particular contours that you don't want. You leave those ones on and you say export. And when you export, you're going to export the ones that you're visually seeing on the screen.
I worked a lot with the Model Maker, and in Model Maker you can, especially about the break lines. So you know there's now a curb line and the contour should break there. So you'd simply switch around the triangle. So when you switch triangles, you sort of quickly introduce a curve line. How would you do that? In other words, you look at the contour and you know, and you've got the image underneath and you know it interpolated across the curve, which it shouldn't do.
Yeah. So we've got dynamic contours. The dynamic contours are then not smooth, they're straight lines, etc. And you can change your surface as you please. And as you change your points, your triangles will update, and as your triangles update, your contours update. It's all dynamically happening in front of your eyes. So let's say you move a point. As you move the point, the triangles will regenerate, and immediately the contours will regenerate.
Or you add a break line, or you add a culvert, or anything like that. You forgot to map your culverts. You can just add them in afterwards, and your triangles automatically update onto those break lines, and then you'll see the contours change. Just changing metadata. But I think we've all kind of seen that now. So if I hover over the contour there, you can see the metadata that's been added, and that we can choose to add more metadata to that, what the source was, who the surveyor was.
Perhaps we can just quickly go over the moving of multiple stretching and moving these things. Classic examples is like a crowded area, or if you look at, sometimes you look at it and you know, obviously you were there, you're the surveyor, something is wrong here. The best, of course, is always to go back to the dam and see what's going on with the dam and why is this happening. But there are times when this is just not possible. You know, there isn't enough data, or you go into the field and now you fix another point and your contours are generated, so you just want to move it. And again, this is where this whole warping process comes in.
So I just added the metadata. And then we just want to do that move, the big move.
At this point in time now, we did a local survey, okay, and now we get some control and we want to bring it onto the national grid. So we've got this whole area here, for example, and we're going to switch on some control points that are common to both systems. And so here we have some points, and you can see we've got quite a radical rotation and scaling over there. Please don't confuse this with our C-point routine. Our C-point routine is another animal, and that's for warping things and fitting, and that's for when the national grid changed and there was a readjustment of the network and all of those options. This is a plane, as it says, okay, over there. Just read, location is move, rotate, and scale. Okay, that's what we're doing here. We're doing those movements with a least squares fit, of course, at the same time, because we've got 4 points now, so we've got redundancy, we've got more points than what we need. So now we're going to say, okay, I'm going to, first of all, that's the area, choose the area, Corin's chosen the area. Then it says, enter monument point from. Always read those things at the bottom. Some people put them at the top. Enter monument point from, and she says, okay, well, that's my other point that's on the other system. And now enter the second monument point. So this is if you just want to quickly move things onto your, and the third, and you just keep on going, as many as you have. And when you press reset, it gives you the results.
So it gives you best fit. Yeah.
When you moved and rotated and scaled, the Z values will then also change. Will the contours regenerate on the different plane?
Okay, so it's optional. Very good question. Move ordinates over there. So we chose to just move the X and Y. Move, rotate, scale, X and Y only. If we had chosen for the X, Y, Z, then everything, and then you're probably going to rerun your contours or something, because now you've got isoclonic planes or whatever they're called. We actually have quite some serious options here on moving the Z, but it's just, I think you guys will just get too... You can move the Zs. There's an option there. Lift it, but that's now planar movement like this. It's not we got the whole surfaces tilted or whatever. But if it's a requirement, we can. At the end of the day, you're going to regenerate your contours if the Z's moved. The The XY is going to change because of it. Okay, so we're going to look at some more details on what we spoke about, this method of inserting vertices. So yeah, we've chosen with this, we're showing you the whole dialog box now so you can see what's happening. When we choose over here the mode, vertex, we have different methods. So the mode is vertex, and the method is to insert or move and delete. They're combined, inserting, moving, remember? And that is determined by your tolerance factors over here. You can have a tapered distance, and let's just see the difference between the two. So that's at a fixed distance, 15 meters either way, that's what your tapered distance is going to be. Okay, so you can see it's fixed, eh? As we're moving, it's 15 meters either side. Not always convenient, but you might decide for a particular survey, those are the tolerances that I allow, and that's how much I'm going to allow it to taper in. So it doesn't matter if there's one vertex or node or 500 of them, they will taper in over that distance. Okay, so the one that we typically recommend, however, is the taper factor. So as we change the method or the taper method, we change it to factor. And now the further you move away, the longer this distance. And you specify what that factor is. So if you're on 1, you have to move it quite far for it to go. So there's your factor, there's your taper factor. If Cara makes it 5, she only moves a little bit. So you can see you can get whatever you want out of it by playing around with that factor. Then you've got a vertex tolerance as well. So the vertex tolerance is saying, well, if I'm within 0.1 square from my contour, 0.1, don't insert one, use that one. Okay, so you don't get extra vertices, 2 vertices right next to each other and things. And that tolerance you can make quite big. You can make it a meter or whatever you want to make. And then you won't be inserting, you'll just be nudging the existing vertices over. Button over there, okay, she's not going to switch it on, okay.
Okay.
Is the one that says no, but everything must move. Now, we realize this is maybe a bit weird for contours, okay? More for a fence. You're going to move your fence from here to here, and you've got these crosses and all labels and all kinds, and everything has to warp, get longer that way, and maybe shorter that way. So more applicable there, but you can find an application for this in contours as well, where you actually say, I've got a spot height, or I know my turn, I'm going to go onto that point over there. And then what it's doing is it's squashing these ones up and it's warping it. So now we've got this metadata that we've added. Remember, the metadata is extra information that's added to the contour, such as the surveyor, etc. Now we're going to say, we want to filter on this, and we're going to now show you that combinations of filters. So that might be quite useful for that type of job where you've now recreated contours in an area. So we got the survey. We're going to show you the total filter dialog box, and you'll see over here that we have a button for each view. It's not often that you're going to sit and click each little button, eh? So we have these lock buttons at the bottom. So if Karen presses one, then they all go on or off. But we have a display and a use. There are times you wanted to use the minor contours for some reason or whatever, but you just don't want it to display. Generally, they go hand in hand. What you see is what you get. Switch the display and the use on or off simultaneously. Filter's off at the moment, so nothing's happening. But as soon as we switch that on, we are now only, because they're green, we're only seeing the survey done by CM Geomatics there. But that's now just one filter that we're running. We want to combine that with some other filter. So let's say the class. We only want to see the major contours of that particular survey, or the minor contours, whatever. So now we only see the major contours of that particular. And now you can start seeing now how this would apply if you've got old contours and new contours and things like this. It's like having a whole host of levels that you can combine all together. And user data. So has this data been edited, or has it been labeled, and has it been checked, etc. So you can really narrow it down, all these combinations of filters that are running. When all else fails, you might have forgotten something on and not realize that your data is not covering the area, and you're really in trouble. Then you just switch off your apply filters and you see everything. So this is your fail-safe button over here.
We've also got profiles here, so you can preset up profiles. So I've got one. You've seen me using them the whole time. We only want to see depression. We only want to see the labeled ones. We only want to see what was done in a particular date. Okay, so you can pre-set up these things so you don't forget.
I don't see a filter from the source of the survey. Very often you want to isolate your Class A survey from the rest of the, for instance, you've got a structure that you've scanned and you want to filter only the information for the bridge or a building or a culvert. Can you extract that through the filter?
Yeah. So whatever you decide those labels are, let's just go to the configuration and show. So there are particular, like the LAS standard, which is an international standard, there are certain predefined like classes, okay? And so the typical one then to use would be class, okay? And so we'd go to our class, but now we haven't catered for what you said. So we'd go to the populate tables, go to class, and we would say, okay, add this particular class. Now we would say, okay, the class is, give me an example.
Scan data or instrument as opposed to photogrammetry.
So maybe class isn't the best one. Maybe you would have used user data or source. Yeah. So you can choose, and you can name it what you want. So let's say you don't like the word source. What would you use?
Well, I would include in there 3D scan data as opposed to LiDAR.
Okay, so
which would be a Class A type survey or a total station type of survey, which would define it as a Class A as opposed to a Class B or first order accuracy, second order accuracy separated.
So the accuracy I set up as a percentage, but you can change that as well. So we can make that a table instead and call it A, B, C as you want.
So then you can extract that from the compilation and work on that separately.
Yeah.
So you can combine your accuracy and with your data source. You could say, okay, this is LiDAR data at that particular accuracy. Show me only that. Show me only LiDAR data at a particular accuracy. On endpoints, you would get that type of thing. In other words, your mass points, what we call endpoints, your mass points. If you've contoured and you want to knock it through to contours, then you're free to carry on and use that same naming convention throughout, you see, in your contours as well. But you can define them separately. That's the point I'm just trying to make, you know, that your point cloud you might define separately to your contour information, because your contour information might not need to know in so much detail of what you got with your point cloud. You might want other information for your contour. Okay, so yeah, it's all individually definable. Okay, let's look at the Raster Manager. While I was doing the development of the Raster Manager, one of the nuisances I found was that I wanted to be able to suddenly go to my browser and have a look at what was available. So we've added, one of the things I want to mention before I forget it, we've added the browser, but we've also added it for DGN. So under utilities, you choose the browse, okay, and it will open your browser with all your files that are there. Okay, so now because we opened the browser under the DGN, we see all our, it took us straight to that directory. Okay, so we've knocked this through to Raster Manager, MDM Manager, etc. And then also gave you the ability to drag and drop your files, of course, into the Raster Manager, which is in the MDM, etc., but wasn't there. So Corin's she opened the browser and she pulled the images across, and there's the 4 or 5 images instead of going file open. You can of course go file open and multiple select if you want to, but sometimes there is obviously just an advantage of using a browser. You might be selecting files from this directory, this one, this one, this one. You can open the browser as many times as you want to, so you can open multiple Explorer sessions and just drag them in, and because they in so many, you might have them on 3 or 4 drives, you know, after you've taken your images, getting them from the field. And so there's a browse folder there as well, and it's going to show us then all the images, and it doesn't matter if you select the same images, it's quite fine. And So we've opened now 25 images and they are now displaying here. So those who are using the MDM will be quite used to this, ons and offs, switching images globally. Right-click on it if you wanted to switch all the images off. Just right-click and say all off. Another useful feature is this auto front option over here. So as Karen clicks on a particular image, that image is brought to the front. Okay, so this is useful when you're trying to set up your soft copy job, for example. You get thousands of images and they're all over the place and you're trying to sort them out, you're trying to look at which images failed, then you would do that. And then another option here is when that button's on, you can just click and zoom through or use your scroll bar. So I'm just highlighting a few of the features that we've added into the new manager that can make it a bit smoother to work with it. Very fast with images, as we said. Okay, so zoom in and out, very quick, even though there's a whole lot of images on top of each other or whatever. You can zoom in and out and scroll, etc. Pan, very fast with images. And remember, these images are not your typical handheld camera. These are images that are touching a gigabyte in size, that it's working with enormous images. And 783 megabytes, one image. They're big images.
Yeah, and we've also, as we said, we've got the mini-me. You saw them in the thing. So that's quite nice. Doesn't take up so much space.
There we'll have a look quickly just at the multi-threading option in the clipping. And so in the clipping over here, we have the extra button over here, which says how many of the cores to use. Most times you just leave it on same as processor cores. And while it's running, you can carry on working. Okay, it's running in the background and working with the processing your images, and you can just carry on working.
We've also added profiles here because I know it got a bit frustrating wanting to change all your options in the clipping. So now there's profiles as well. Set it up, done, stored. I know this button, for instance, you forget it off sometimes and then it goes quite slowly. So now you won't forget to switch it on because it's on in your profile.
Question from Gordon McGill. Is 8 cores is the maximum?
No, we just put the first 8 there. So if you have 16 cores or whatever you have, then you just put it on same as processor cores, and then it uses all of them. Okay, but if he says nobody wants to, because normally you won't limit it. You just generally won't limit it in the application. It's quite possibly more for our testing purposes, but it will use, when it's the same as processor cores, it uses all the cores. Okay, just takes the whole lot. You're going to find more and more heavy intensive things coming online with this multi-threading, and particularly when you switch to 64-bit, etc., full 64-bit, then we will be, there's certain times when it's not applicable though.
His reply is, I do want to limit it.
Okay, so what we could do is we could add an option there, user specified as one of those options, and then he could type in a value there, 12 or whatever. So we'll add that as an option.
Are the multiple cores available to the convert tab as well?
Yeah, so the batch processor, yes. Later, the batch processor, as I said, your bottleneck there is your drive, because when you're doing batch conversions, there's not much processing. So you do get a speed advantage, okay, but it's not 3 times faster unless you start splitting your destinations. So if you split your images to go to different drives, so you're writing to different drives simultaneously.
At least you can carry on working.
Yeah, you can carry on working if you run it in the multi.
Yeah, because it's busy running in the background.
So the bottleneck with straight batch conversions, where there's very little processing happening, when we're running this, and you've got 8 cores, it's running those 8 cores flat out, 100%. So you need a good cooling system. You're probably going to have to up your cooling system on your computer because it's flat out.
Yeah, I just want to say a very big thank you to everybody for coming, and I hope that it's been informative and exciting as we are excited about this. Okay, thank you very much.